Hey, stats class. I'm gone today again for a different reason this time. Daycare's closed today, so I would have been back, but yeah, daycare's closed today, so I'm home with my kiddos. So I'm going to go ahead and walk you through just about half of the notes for section 2.1. I think I'm going to only get to, if you flip over to the second page, probably right here to critical thinking is where I'll stop. So this video won't be too terrible long, I hope, but they're starting you into frequency distributions, which we'll talk about what that is. But I do have your test graded, and I'll give you back those on Tuesday when I come back. So there's how that works. All right. So frequency distribution is a frequency table. What this, if you look at this table, what they've got going on here is they said the age of best actress when Oscar was won. Okay, actress means females, so we're going to compare later on in this section, I think, or maybe tomorrow, or maybe section 2.2, they compare actors versus actress, but they're sectioning these off 20 to 29 years old, 30 to 39 years old, 40 to 49 years old, et cetera, all the way down, okay? And they're showing you the frequency. So there was 29 people who won Best Actor or Best Actress when they were 20 to 29 years old, 34 that were in the 30 to 39-year-old range, and then fewer and fewer. This kind of tells me that, like, hey, most of the women are winning the Oscars when they're in this age range. Doesn't mean it's impossible to win the Oscar when you're older, but most of them are winning in this age range, okay? So that's how the frequency table is dissected. There's 29 in this range. Now, the bad thing about a frequency table is that we don't necessarily know what age they were exactly. So of these 29 people, which ones were 21, which ones were 27? You know, we don't know those data values individually. All I know is that there was 29 in this range. So there's good and bad about a frequency table, but that's how that works, okay? So we dissect this frequency table and we start talking about lower class limits, okay? So the lower class limits are going to be all of these numbers that are on the lower end, so the 20, 30, 40, etc., all right? So I'm going to say the left bound, and that would be, if we use the example over here, this would be 20, 30, 40, 50, etc. The upper class limits are then the other ones, so that would be the right bound of each class. Right bound. I can't write as fast when I'm doing this. 29, 39, 49, and my writing is way worse. Okay, so left bound, right bound. By the way, these are called classes. Each one of these is a class. So classes, if you didn't already figure that out. Each one of those are classes, okay? So left bound, right bound, those are upper and lower class limits, all right? Then this one is what people confuse all the time, class boundary, okay? So we basically have to have a boundary that designates what goes into what, okay? So let's say that the actress was 29 years old and 364 days, meaning that tomorrow would be her 30th birthday. Do we lump her into the 29 category or do we lump her into the 30 category? So what we do is for class boundaries, we average the lower and upper limit. Okay, so what that would be is, like, we would average the 29 and the 30 together, which would be 29.5. Okay, so basically that's saying that, like, hey, if we have somebody who is 29 years old and 364 days, they're not yet 30, but we're still going to round them up into the 30 category because they are older than 29.5. Okay, so in each one of these, we're gonna call a class boundary, basically like the cutoff point, the imaginary cutoff point that is here, that would lump them into the next category. Even though they're not exactly 30, we're going to lump them into that category. So there is one for each one of these. There's 29.5. The next one would be 39.5, and then 49.5, and etc., right? It would go on, and each one of these, if it was higher than 29.5 or lower than 29.5, it would go in those respective categories. Okay, so there's that. Class midpoint, you're going to average, I'm going to say average bounds per class. So you're going to average the boundaries for the class. So to do that, you would take like 20 plus 29 divided by 2. That's the average just in that class. Okay, so we're not averaging the 29 and the 30. We're averaging the 20 and the 29. So these two right here. If you add those two together and divide by 2, you're going to get a decimal, which is fine. You'll get 24.5. So that is the midpoint. 24.5. And then the next one would be 34.5. Okay, so we're the middle of the class. The middle of the class is exactly between those. 34.5. 44.5, etc. And it would go on for all of those classes. It would keep going up to 84.5, etc. Right? All right, the last one is the class widths. And people say the class width is 9. I'm going to put over here a little note. Not 9. The class width, how wide the class is not 9. Not 9. How you determine class width is you take the lower bound minus the lower bound, or the upper bound minus the upper bound. 30 minus 20 is 10. 39 minus 20 is 10. Okay, so it's not a distance of 9. You're not going from here to here. You're going from here to here. That's 10 units. Okay, so I'm going to say the class width is only 10. And there's only one number for class width. You're not listing out all of the rest of them like this one. So I'm going to say L to L, or U to U. Lower to lower or upper to upper. Both of those should be the same distance. So there is that. Going down here, this is just kind of breaking down how you make a frequency table when you have a bunch of data. So what you do, the first thing is you have to figure out how many categories you want. In this one, they had 1, 2, 3, 4, 5, 6, 7 categories. Okay, you have to figure out how broken down you want your categories to be. So do you want 7? Do you want 5? Do you want 10? How many do you want? Usually it's between 5 and 20. You'll have listed out here. If you have a lot of data that has a really big range from like 0 to like a million, you might want 20 categories because your data is going to be really spread out. Okay, so 5 to 20 categories is usually standard. You just have to figure out how many you want. Okay, the class width, you take the highest data value and you subtract the lowest data value, and then you divide by the number of classes that you want, and that will tell you how wide you need to put your spacings here. Okay, we'll go through all of this in this data down below here. Okay, so number 3, choose the value for the first lower class limit by using either the minimum value or the convenient value. So maybe my lowest number was 22. I could either use 22 to start with, or I could go a nice even number, 20 to 29, okay, rather than going 22. Using the first lower class limit and the class width, list the other limits, etc. So then you're going to figure out what your classes are here, and then you're going to tally up and do your frequency table, okay? So I'm going to do all that stuff down here. They want 5 classes for these guys, okay? And there are, let's see, 3 times 2, 4, 6, 8, 10, 12, 14, 16, 17, 3 times 17, and then there's not one in that last category, so whatever 3 times 17 is. 51, so 50. 50 little things here, okay? And these are drive-through service times for McDonald's lunches. So it took 90 seconds for somebody to go through the drive-through. It took 308 seconds for somebody to go through the drive-through. That's like 5 minutes. So all of these are all in seconds, how long it's taking to go through the drive-through. We need to figure out what our classes are going to be over here. So let's see, use the 5 classes. We need to figure out our lowest number. Here's my pen here. L-O-W-E-S-T. Lowest number is 83, I think. 83. Okay. Your highest number, biggest number is, I see a 308. That might be the biggest one. 308. 308. So, to determine your class width, how big you need your classes to be across, we're going to do 308 minus 83. This is this formula right here, the maximum data value minus the minimum divided by the number of classes. So 308 minus 83, all over, we want 5 classes. Oh man, now I'm going to have to do math and I don't have a calculator. 2, 2, 5, 225, I think. Let me make sure that's right. 225, yep. Divided by 5, so 45. 45 is going to be our class width. 45. Okay, so let's go ahead and start with, even though it's not a nice number, let's start with 83. Okay, 83 is going to be my first number here. Okay, now, if I add 45 to that, so my class width is going to be 45. If I add 45 to 83, that is 128. 128, since we're talking class width is from here to here and not from here to here. So class width, we're going 83 to 128 down there. All right, that means this one has to be 127. Okay, 128, if we add 45 to that, would be 173. That means this guy would have to be 172. All right, add 45 to that, that would be 218, 218. All right, so that means this guy would have to be 217. All right, 218, add 45 to that is 263, and this would be 262. And if I add 45 to 263, I get, oh my lord, 308. Is that right? I feel like maybe I messed up a little bit, because 308 needs to be in this data range. My math is off somewhere. 308 should be my highest number up here to cover all of those. 83838. Nope. Huh. Maximum data value. Huh. Poop. Maybe we should have done our class limits as 46 then, because my problem here is that this is 307 and 308 is my biggest number, so it doesn't fit into there. Maybe we should have done 46. Yeah, I think there's a rule with rounding. That should have been 46. Anyway, so let's just leave it the way that it is. Whatever, we'll just pretend 308 is in there. And then we would go through and we would tally up. So we would look here, 107 is my first number. 107 fits into this range, and I would put a 1 there. 139 is my next number. It goes here. 197 goes here. 209 goes here again, and etc. And I would keep tallying them up until I would get a number. So maybe there's 7 total here, and 9 total here, and 14 here, and 21 here, and blah, blah, blah. And I would go ahead and do that all for the number of tallies that I have in each category. Okay, and that would give me my frequency table. So shoot, yeah, we should have rounded that up to 46. I'm not going to do the whole thing again because that's just going to make this video longer. But yeah, 46 is what we should have done instead. Sorry about that. So if you have questions about that, we can go over that again, but I didn't want to spend all the time going through each one of those. You can if you want, but I'm not going to spend all the time doing that. Okay, so how do we go to my next page? Next page. There we go. Okay, so this one right here, emergency room visits for inquiries from sports and recreation. Table 2.3 lists data for the highest 7 sources of injuries resulting in a visit to the hospital emergency room. So bicycling has the most. How is that the most? What? And ATVs are the least. That's ridiculous. Those should be like switched around. Football, I buy that. There's a lot of injuries from football. Playground equipment, that's odd. Basketball, soccer, baseball. Okay, whatever. I think ATV should be higher probably, but anyway, we'll go with it. This is the data that we have. So the activity names are categorical data and nominal level of measurement, but we can create a frequency distribution as shown. It might be surprising to see that bicycling is at the top of the list, but this doesn't mean that bicycling is the most dangerous of these activities. Ah, there's where they get to it. Many more people bicycle than play football or ride all-terrain vehicles. or do any other list of activities. So, okay, I buy that. Because there's more bicyclers, you're going to have more accidents. And definitely bicycling happens more often than ATVs. So even though you hear of a lot of ATV accidents, there's just about every child ever has ridden a bicycle versus how many kids have ever, driven one of those little ATVs. So, I guess that's how that works out. So what they're getting at with this is over on the front side, we had just numerical classes right here where we had a range. This one is categorical data right here. So you have categories and frequency rather than having, your class limits and stuff. Okay, so you can have a frequency distribution or a frequency table that has just categories. Okay, now relative frequency and cumulative frequency, I'm going to stop after I talk about those because I don't want this video to last forever. Relative frequency and cumulative frequency. If this is your regular frequency table, this is again talking about the, I think this is the McDonald's data that we were supposed to do. Anyway, they went 75, they went 25, or they went 45 instead of, no, I don't know what they did. 75 to 124, 125 to 174, blah, 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 all the way through. But then the frequencies are 11 to 24, 10, 3, 2. So hardly ever are you ever having to wait more than 275 seconds for your food. Most of the time it's going to be between 125 seconds, which is 2 minutes, and just under 3 minutes. So 2 to 3 minutes is what you're going to usually wait for your food at the McDonald's drive-thru. Okay, so relative frequency, what this would be is, since we know that there's, I think 50 in here. Yeah, 50. There's 50 data points in here. Relative frequency would be 11 over 50. Let me write with my pen, sorry. 11 over 50 is what this relative frequency would be, but then we convert that to a decimal or a percentage. 11 over 50 is 22%. So 22% of all my stuff is going to be in this this category, 75 to 124. Okay, 24 over 50 is what this one is, or 48%. Okay, 10 over 50 or 20%, 3 over 50 or 6%, and 2 over 50 or 4%. And you're like, how are you doing that so fast? If you're going out of 50, normally percentages are out of, always percentages are out of 100. So 50 times 2 will give you 100. Each one of these times 2 will give you what their percent is. So that makes it really nice. If you're wondering like how I'm a magician and how I multiply so fast, there you go. So again, we can see that 48% of the time you're going to wait between 2 to 3 minutes. Okay, so there's that relative frequency. Now cumulative frequency kind of goes back off of this table right here, this guy. And cumulative frequency looks like this. This would be 11. This would be 35. This would be 45. This would be 48. And this would be 50. Okay, now here's what these numbers mean. This 11 goes straight from this 11, but then cumulative frequency is you're accumulating it, right? If you have a cumulative test, it's like all of the stuff before that. So this in this slot is going to be 24 plus 11. That's 35. In this slot is going to be 10 plus 24 plus 11, 45. In this slot, this 48 is these four added together, and 50 is all of them added together. So the cumulative frequency is important because you can say like, how many of these 50 had a time that was less than 274? How many of them were less than 274? That would be this category and this category and this category and this category. Okay, so it would be all of them added together, or since I have cumulative frequency, I can just note that that is 48. So that's what that cumulative frequency is for. Or I can say what number was below 175. 175 would be just these two categories, and that's 35. Okay, so cumulative frequency is helpful. I'm going to go ahead and stop this video there. I am going to post the homework. Go to the homework page now and do the problems that you can. Okay, you'll know if you can't, because it'll be stuff that's we didn't talk about down here. So they'll be setting up frequency tables, doing all that good stuff. Do the homework. If you are missing any homework from chapter 1, you need to do it now as well, because I am putting those grades in the grade book this afternoon. So make sure that you have those turned in. Okay? Stopping the video.
Mommy.